So I want to tell you about string encodings and Unicode. You said you have no idea what Unicode is, right?
Exactly. What is Unicode?
What is Unicode? Okay, so I made a text file, called it words.txt, and I have these different types of characters on it. I like pi. let me put hello world here. Okay, hello world. I like pi to infinity and beyond. 你好世界. That's Chinese. We're both Chinese speakers, so we can understand this. Other people watching, they're out of the loop. But we can also put some emojis here. What do you think would happen if I wrote a Node.js program to read in this file and go through the string and print out character by character?
I'm not sure. Well, I guess if it's English, just like English, it will just print out the which format are you gonna print out? Are you gonna print out like just the character? Because I remember you can print out like to like some sort of code. Wait, is that Unicode?
Print out to, what do you mean some sort of code?
Like I remember when you have like a read file and then you can read it to like different format. There is like a parameter you can
Exactly. That's called encoding. Oh, you probably looked at the TypeScript definition of the read file function.
Yes.
So anyway, I'm gonna write a Node.js script that's gonna read in the file and loop through each character of the string and print it out. Node.js has this fs.promises API now, comes out of the box if you want to use async await with the file system. I just alias it like this now, so that when I say fs, I actually mean fs.promises. So this is how I do it now. Okay, so now that it's the promise version of fs, I can await on the read file because it's a promise. And then the thing I get back is actually a buffer, if you remember. We're gonna talk about the buffer also, but for now, I'm gonna convert it to a string because that's how you learn to read in text files in Node.js. You convert the buffer to a string.
So is the buffer like the byte?
Yes, buffer gives you a byte array representation of the content. But we're gonna toString it, and there's actually some magic to the toString. I'm just gonna loop through in the most classic way possible. Gonna write a for loop like I'm writing C. I just use index notation to get each character. Alternatively, you could have done like char at, like that, but it doesn't really matter which one you use. I'm just gonna stick to this one because it looks very low level. Okay, so I'm gonna print out character by character to the screen. I'll print out the index number and the character. So the file I made is called readfile.js. I'll run that. What just happened?
We have the module.
Promises. This should be promises plural. Okay, so it did that. So notice that we got some of the characters to come out. Hello world. I like pi to infinity and beyond, but there's some characters at the end that did not come out. And the ones that did not come out are the emojis. But the Chinese characters came out okay, and the weird Greek letters also came out okay. So that's interesting. Let's change it to read the bytes. What would happen if we read the bytes? So I'll make another file, called it read file byte. I'm just gonna make a copy of this file, and instead of looping through the string, I'm looping through the buffer. So I'm gonna get rid of the string. At this time, I'm just looping through the buffer. And when you're looping through the buffer and getting every element of the buffer, each value is a byte. And that's actually gonna be a number. So I'm gonna print out the byte, and let's run this file. So now I'm going to read file byte.js bytes, and you get these numbers. Each number is a number between negative 127, I think, to positive 128. I believe, because a byte is a 8-bit number. A 8-bit number is like 01001101. That's a byte. So each byte I'm printing out is a 8-digit binary number, and if you do 2 to the 8, that's how many possible combinations you can have. And if you want to represent negative numbers, then you split the 256 in half. Half of those get to be negative numbers, and half of those get to be positive numbers. If you're going to say, no, I'm only representing positive numbers, then you get to represent starting from 0 to 255, right?
Wait, why do we need negative numbers here?
We actually don't need negative numbers, but traditionally, well, the first American character set is called Ascii. Have you heard of Ascii before?
Yes.
Yeah. So Ascii represents 127 characters, I believe. It includes all the digits from 0 to 9. It includes the uppercase A to Z and lowercase a to z. The Ascii standard use only 7 bits. So it only uses 7 of these. That is enough for Ascii. So we didn't actually need an entire byte. There's 1 bit extra that Ascii is not even using. But later on we standardized on using 8 bits for a lot of different types of things. So using a byte, it's just so commonplace that you're not gonna write a program that uses 8 bits. That just never happens anymore. You always use a multiple of 8, either 8 bits or 16 or 32 or 64, right? So it's just a given that you're gonna use at least 8 bits, at least a byte. So then there's an extra bit is like, well, what does that do? We'll get to that. I hope I have the internet because I kind of wanted to show you AsciiTable.com. Okay, so yeah, this is all of Ascii, right? It starts from code 0 to code 127, which is the delete key.
Okay.
And the alpha numerals, they're in here somewhere, and there's the space and the exclamation point. Everything that's on your keyboard is on here somewhere, right? But obviously that's a problem because where are our pi's and infinities and Chinese characters and our emojis? Those are not there. I have a number, right? A byte is a number. How can I get the character representation, which that number is based on? In JavaScript is string dot from char code. This byte is some ASCII code, right? This byte number is some ASCII code. Yep. And from the ASCII code, I can get JavaScript to tell me, give me a character based on that ASCII code. So we can do this. Yeah, let's do that. So print out both the code and the character. And you'll see that, yeah, the hello world that comes out fine. I like comes out fine. The pi did not come out.
Oh, okay.
To infinity did not come out and beyond. And the Chinese characters did not come out. And the emojis also did not come out.
So what are the stuff that's showing up here for the thing that doesn't come out?
Oh, like why do we have weird characters here?
Yes.
Like there's a fraction, 1/2 fraction and a 1/4 fraction. That's weird. So it turns out that later on, remember we said there's 8 bits, right? But ASCII only uses 7 of the bits. Later on, people said, well, that's kind of, I can do a lot with that extra bit. I can represent another 128 characters with that extra bit. So then they just said they brought in an extra 128 characters. They called that extended ASCII. And then they added extra characters like this A with the 2 dots on the top, and is this yen or something? I don't know. And this fraction. They brought in extra characters because there's a whole extra bit that we can use to get 128 more combinations. So this is basically falling back to that. When we told the terminal display this ASCII code, and the terminal is like, well, this is out of the ASCII range, so it uses the extended ASCII. But obviously, the extended ASCII still cannot represent Chinese characters and emojis. There's not enough combinations to represent all that many different things, right? Because those are way out of range. If you wanted to represent all of the Chinese characters, you need a lot of different combinations to do it.
Right.
So this is not enough. So what is the solution? The solution that we thought was going to be fine at some point. This was in the 90s at some point, I think. And I remember when I was in college, people were talking about this, is we'll just extend it to 16 bits.
Okay.
If we have 16, then we can represent a lot more. We can actually represent 2 to the 16, which is 65,536 different possible characters in the character set.
That's not enough.
Exactly. That's not enough. But back in the 90s, people thought that was enough. Like, this is all we need. We're good now. We have 65K some characters, and we're enough. So the Unicode is a table that has all characters that we might ever want. So there's a group of people that standardized it and created the Unicode, which is a mapping of characters to numbers. How many characters are in Unicode? There's more than 1 million characters in the Unicode standard, which is obviously more than 65,000. So you're like, how can 65,000 work? Well, people thought that would work, but it didn't work. So this is the Unicode table. You can see some of the letters that are in this extended ASCII set, the 1/2 and the 1/4. That's still within the 256 range, right? You can go down to the Chinese character ranges, and you can see the Chinese characters are within the 65,000 range. So if you have 65,000 something characters, you can actually represent Chinese characters and a lot of different languages in the world.
My friend has very weird Chinese name that is not like the normal character, and so their name always just show up like blank on the screen. It's probably
Nice. Yeah, maybe I can type it. Do you know a character in their name that's weird? I can try to use pinyin.
So it's like DI. Okay, so it's not on this page, of course. Go down and go down. I believe it might not be on this.
There are some Chinese characters that are after the 65K range.
Yeah, exactly.
That because they had to supplement it. They realized there's some they missed, and then later on they added to the standard. Printing the bytes divides them into 8-bit chunks, right? But the first program that I wrote, which iterated through the characters, guess what is the chunk size there? It's 16 bits. If you loop through the string based on string.length and you use the indexing to get at each character, then the character is represented by 16 bits. At one point, people who made programming languages thought 16 bits is all we needed to represent all possible characters. And they designed a programming language like Java, JavaScript. They basically said, I'm going to make this thing called the wide character. Previously, characters were 8 bits. We're going to have wide characters in Java, and a character is 16 bits. And then, of course, later on, they realized actually even 16 bits is not enough. So how are we going to iterate through the emojis and any character that's outside of the 65K limit? Well, let me make another version of this file. Interestingly, they added a new feature of JavaScript such that if you iterate through the string differently, everything just works. So if instead of using the classical for loop, you switched it to for, why am I using var? I should use let or const always, obviously. If you switch to the for of loop to iterate to the string, and then you print out the character, everything just works amazingly. Why? See, our Unicode characters are coming out correct now.
Okay.
And the Chinese character, basically all of the characters are coming out correctly. All you have to do is change the for loop to a for of loop. Why is that? Well, so at some point JavaScript introduced a thing called iterators. Do you know about iterators?
No.
So iterator is like symbol.iterator symbol, which you can use as a key.
It's like the iterable thing, and then you can just loop through.
Yeah.
Things. Okay.
You've seen this weird thing, right?
Yes.
But once you have this iterator thing, then you can keep calling iterator.next, right?
Yeah.
So we'll just call it like a few times and print it out. But basically, this is the low level way that this stuff works. But the for of loop is internally using this iterator.
Okay.
So yeah, that worked. So if you do it this low level way, you call this symbol iterator method, and then you get the iterator and you call .next until the done becomes true. So you would write a while loop, right? Like this, like while true result is iterator.next, and then you'll say if result.done, I'm gonna break out of the loop, right? And then you'll print the result here. So if you had done this, it'll loop through based on this iterator and print out all of the characters. So that works. And yeah, there's this wrapper object that has the value plus the done value, right? I can just do that value if I don't want to see all this stuff. But internally, that's basically what for of does. For of does that. So basically, they define a special string iterator that understands Unicode. It will know if this character requires more than 2 bytes to represent, based on the encoding of the character. And then if it does require more bytes, for those multi-byte characters, it'll actually be more than one in length. So I can show you that by doing char.length, because char is also a string, right? I don't need this guy anymore. Yeah, so these things have length 1, but if you get down to the emojis have a length of 2. The Chinese characters still have a length of 1 because they fit into that 65,000 boundary. So emojis came really, really late, so they have to come after the 65,000K boundary. Or very unusual Chinese characters also come after that, right?
So how does it know? How does the iterator know these are like
multi-byte?
These are
Great question. So I wrote some other programs. I'm gonna run this one called read file unified, and I'm gonna post this code on GitHub later, so in case you or other people watching want to see them. So I wrote several versions of this read file program. I'm gonna run one that will show you the binary encoding in all 3 sizes. In 8-bit sizes, in 16-bit sizes, and in 32-bit sizes, all together, side by side. If it works. Okay, let me fix the syntax error. Oh, I was trying to write this function, and then I get distracted and went to do something else probably. Okay, I'm actually, because there's so much input, I'm gonna take away some of the characters so that you can see everything in one screen. So maybe I'm gonna put I'm just gonna put hello on one line, and then pi and infinity, And then let's put the Chinese characters and then the emojis here. Okay. Okay, so now I can see everything in one screen. So if I don't know why I have the 8 bits in the middle, but the 8-bit representation is this center column. The 16-bit representation is this column to the right, and the 32-bit representation is the column over here to the left. This decimal and hex columns, those are the numbers that represent the character number within the Unicode system. Because the Unicode system is doesn't care about how many bits you're using to represent the number. The Unicode system is just like a character 0 is the number 48. It's just based on a straight number line. But if once you encode that number, which might be very, very big, like a million, if you need to represent the number a million, you're going to need more than 8 bits or 16 bits. You're going to need 32 bits to represent a million. So how do you represent a very, very large number in 8 bits? Well, the first byte is going to have to tell you that there's actually more bytes coming behind me, right? And and the way you tell the program that's reading you that there's more bytes coming after you is you flip this first bit to 1. You see how all the ones that require only 1 byte have a 0 at the beginning, right?
Okay.
So these ones are the ones that fit into the Ascii set. They only require 1 byte to represent. But if there's multiple bytes that are needed, the first bit is going to be 1. That tells you there's more bytes. How many bytes are coming after me? That's based on how many ones come after the first one.
What?
So you said this one, there's 1 that comes after this one. So that means there's 1 more byte coming after me.
Oh.
So this one means there's more bytes. And this one is like there's 1 more byte. And then the next one is 0. That means, there's no more. There's just 1 more byte. But for the one that has 2 more bytes, it's a 111. See? There's 2 more ones after the first one. That means 2 more bytes are coming. And then for the one that needs 4 bytes, it's 1111. The first one is the signal bit. And then we have 3 more ones to tell you that there's 3 more bytes that are coming after.
Oh, okay. Interesting.
Yeah, so it's a variable length characters, basically.
Okay.
And if you're writing a program that needs to interpret this correctly, you need to write logic to handle this encoding. And that's why this concept called encoding is important, because you can't interpret a file that contains text in it unless you know what encoding it was encoded in. Right? Is it encoded based on UTF-8, or was it encoded based on UTF-16 or UTF-32? So with UTF-32, the problem does not exist because 32-bit is enough to represent more than a million. Actually, a lot more than a million. So if you use 32 bits, you'll probably be able to represent all possible characters in another century or whatever.
Unless we have too many emojis, then we're going to blow it up.
Yeah. But the problem with UTF-32 is, look how wasteful we are. We have all these zeros. Like, we're using all of these extra memory, and we're just filling up with useless information. They're just zeros.
Yeah, that is true.
So if you're going to write your web page, for example, and you're going to encode it in UTF-32, the transfer of your web page is going to take a lot more bandwidth and also a lot more disk space to store the file on disk, right?
Yeah.
And also a lot more memory for the web server that has to load the stuff into its memory. Maybe. Well, if it's a streaming web server, not as big a problem, but it's still there. So that's why UTF-32 is not popular, and UTF-8 is actually the most popular one. That is used for file encodings. When you write code and you save the code as a .javascript file, .ts file, it's usually being saved as UTF-8 because it saves space, right? The files are smaller. You transfer it, the transfer is smaller, faster, etc. However, UTF-16 is very popular in programming languages, as in when a programming language reads in your file, it will convert, like usually the file is in UTF-8, but in memory, it will convert it into UTF-16 because the languages thought that was a good idea at the time.
I see.
So JavaScript does this, Java does this. Even though JavaScript, when it reads a file, it'll default to using UTF-8 to interpret the file. When it gets into memory, it has translated it into UTF-16.
That makes sense.
So when you have a string in JavaScript, it looks like this. And I won't explain how it's like it's a similar concept. There's some bits that signal the fact that there's one more chunk coming after me, basically. But yeah, the 16 bits is able to represent a lot more, and you're only ever gonna have one more chunk coming after you, because one more chunk gives you 32, and that can represent enough, like all of the characters in Unicode. So that's how that's kind of how Unicode works. I honestly didn't know a lot of this until this last week when I went reading up about it. And if you're wondering about Node.js, the buffer.toString method actually has an encoding parameter that's optional, and it defaults to UTF-8.
Yeah, that was what I was.
So usually text files are encoded in UTF-8, so that's not a problem for you. You never had to put that in. But in the very, very rare case, if the words are encoded in a different encoding, like UTF-16 Little Indian, then you're gonna have to specify that in order to parse it correctly. Otherwise, everything looks like garbage if you get it wrong.
Yeah, that makes sense. Yeah, I think I had the experience of I just have txt file, and then I had some sort of software trying to load that, and obviously that software doesn't have the ability to load the right encoding in it, so I just see like some weird stuff.
Yeah. Thanks for joining me on this video.
Cool, thanks for sharing the knowledge. This is very interesting.